Hi everyone, you're welcome to today's lecture. Today we shall be discussing on the topic lines, and in particular we'll be looking at the ratio of division of a line segment. So let us quickly try to understand what today's lesson will be talking about. So if we have our rectangular coordinates as we had in the last lecture, and we have a line here, say line AB, and this line goes through 2 points, say point P1 and point P2. Point P1 has coordinate x1, y1. Point P2 has coordinates x2, y2. Now suppose this line AB is divided somewhere here between the point A and B by another point, say P, with coordinates x and y. Now if this point P divides the line P1, P2 in the ratio M1 and M2, our focus in today's class is to find out, or is to know, what the coordinates of P will be, because P1 has coordinates x1, y1, which is known. P2 has coordinates x2, y2, which is also known. Now this point that divides the line A and B internally has coordinates x and y, which are not known. So in today's class, we want to learn how to get the coordinates of this point P. Now the other case also is a case where point P1 and P2, the line segment is divided externally by the point P. Here P divides P1 and P2 internally, and on this other in this other line, the point P divides P1 and P2 externally. So we're looking at what we call internal division as well as external division of a line segment. So let us look at this diagram. We say, let P1 with the point x1, y1, P2 with the point x2, y2 be given points on this line. I call this line TS, such that P1P from here to here is to P2 is to P2 is equal to M1 is to M2. So the point P with coordinates x and y divides the point P1, the line segment P1, P2 internally in the ratio M1 and M2. So we say P1 is to P is to what? P is to P2. And what ratio is that? P1 to P. P1 to P is M1 and P to P2 is M2. So we establish this. We now say, then the point PXY which lies between P1 and P2 is said to divide this line segment internally, because it's between the points P1 and P2 in the ratio M1 is to M2. From this diagram, we get the following. We see that P1R1, this line P1R1, this line PR, and this other line P2R2 are all drawn parallel to the y-axis, and they meet the x-axis at the points R1, R, and R2 respectively. With this, we get the following. We get that line OR1 is equal to x1. Line OR1, this point OR1, this point R1 has x coordinates, which is x1. So line OR1, this line, the x coordinate of this point is x1. Also, line R1P1 is equal to Y1. R1P1, that is the P coordinate of this line, is Y1, and the X coordinate is X1. Similarly, line OR has X coordinate, which is what? X. Has X coordinate, which is X. And line RP, where is RP? Line RP, the same line RP has Y coordinate, which is what? Y. And lastly, line OR2 has X coordinates X2, and line R2P2 has Y coordinates what? Y2. So we take note of this relationship. We continue. Now, what do we see? We say, okay, since line P1Q1 and line PQ2 are parallel, since line P1, where's P1 again? P1Q1 and line PQ2 are parallel. As you can see, this line P1Q1 and PQ2 are parallel lines. We also have the following. We can establish the following with that. We now see that line P1Q1 is equal to line R1R. Line P1Q1 is equal to line R1. Where's R1 again? R1R, of course. It's a rectangle. And that is equal to what? Line OR minus line OR1. How? We said line P1Q1 is equal to line R1R, which is equal to what? Now, how do we get this is equal to OR minus OR1? Are we there? Yes. To get this line from P1 to Q is equal to OR minus OR1. If we do the subtraction here, we get line P1Q1. And what is this? What is OR? From what we have here, OR is X minus what is OR1? OR1 is X1, So with that, we have our first equation, which we shall call equation 1. Again, we have that line PQ2, the other parallel line PQ2 will be what? Will be equal to line RR2, which is equal to line OR2 minus line OR. Let's look at it again. Line PQ2, this other line here, is equal to line RR2. Of course, it's a rectangle, so the opposite sides are equal. So line PQ2 is equal to line R. So line OR2 from here is X2 minus line OR from here is X, and this is my second equation. Also, if we consider line Q1P, let's look at it. Line Q1P, this other line here, Q1P, we have that this is equal to line RP minus line RQ1, which is equal to line RP minus line R1P1, and that is equal to Y minus Y1. We'll call this equation 3. Let's look at it again together. So we're saying that Q1P Q1P, this line here, is equal to RP. Where is RP? Is equal to RP minus RQ1, of course. For us to get this small line from Q1 to P, we say, okay, RP minus RQ1. That is correct. And it is equal to RP again minus R1P1. How? Look, if you observe from this diagram, you see that the line RQ1 is the same as the line R1P1 because it's a rectangle and the opposite sides are equal. So this is correct. And then from our diagram here, what is our RP? Our RP is Y, and our R1P1 is Y1. So that gives us our third equation. We'll go ahead now and get the last equation, then we'll proceed. Lastly, line Q2 P2 is equal to line R2 P2 minus line R2 Q2 equal to line R2 P2 minus line RP. That gives us Y2 minus Y. I call it equation 4. Now let's look at it together once again. Back to the diagram. We are saying here that line Q2 P2, the other small line here, is equal to line R2 P2 again minus line R2 Q2. Of course, when we do this, that gives us the line Q2 and P2. And this is equal to, again, R2 P2 is still here minus, now R2 Q2 is the same line as RP because RP Q2 and R2 is a rectangle. RP Q2 R2 is a rectangle. So R2 Q2 rather is the same as RP. So we replace R2 Q2 with RP. From what we established here earlier, R2 P2 is Y2 and line RP is Y. So that gives us Y2 minus Y. And that gives us the fourth equation from the diagram. Now we consider triangle. Consider triangle P1 Q1P and triangle PQ2 and P2. These triangles are similar triangles. So similar triangles are triangles that have the same shape. So we're looking at triangle P1 Q1 and P, and triangle PQ2 and P2. P1 Q1 P, PQ2 and Q2. PQ2 and P2 rather are similar triangles. Because they're similar triangles, we get the following. Now, we have here M1 and M2, that is the ratio of division. So we have that M1 over M2 is equal to what? From the diagram, M1 is the line P1 and P, right? So M1 is the line P1 and P over M2 is the line P2. M2 is a line P and P2. And this is equal to P1 Q1. This is equal to, so P1 Q1, this line here in this other triangle, P1 Q1 over PQ2. PQ2, since the triangles are similar, so their sides are in a ratio. So P1 Q1 over PQ2. This is equal to, again, Q1P over Q2P2. Q1P, this other side here, Q1P over Q2P2. Now, if you observe here, you see that we have related the three sides of these triangles. The first side was P1P over P2. Second one was this side, P1Q1 and PQ2. And the third one is Q1P and Q2P2. Now, why have we done this? We have done this because the triangles P1Q1P, PQ2P2 are similar triangles. What do we get from all this? Since we have this term equal to this term equal to this term equal to this term, we are at liberty to pick any two pairs and work with them. So in the first instance, I want to pick M1 over M2 equal to, I pick P1 Q1, I pick P1 Q1 over P Q2. And what is this? This is nothing but, what is P1 Q1? P1 Q1 from here, we have that P1 Q1 is x minus x1, is x minus x1 over PQ2. PQ2 is x2 minus x. PQ2 is x2 minus x. So this implies that we have M1 over M2 is equal to x minus x1 over x2 minus x. I will now work with this. So if we do our cross multiplication, what we like saying cross multiplication, if we do that here, we will now have M1, we multiply this with M1 into x2 minus x equal to M2 into x minus x1. Okay, so if we work this out, if we expand this, of course, we're going to get, let's expand over here, we're going to get M1, x2 minus M1 x. Of course, that is equal to M2x minus M2 x1. We now take like terms. We want to bring the x together. So there's x here, there's x here. So we now say, okay, that gives us M1, or let's say M2 first. That gives us M1 x2 minus plus rather M2 x2. We'll take this one to the left hand side, is equal to M2x and then plus M1 of x. So if you look at the right hand side, you see that x is common, so we can factorize x. If we do that, we'll have that M1 x2 plus M2 x2 is equal to factorize x. What we have left is M1 plus M2. If you like, you can write it as M2 plus M1. There is no problem with this. If we divide both sides by M1 plus M2 to get the value of x, then we're going to have x equal to M1 x2 plus M2 x2 divided by M1 plus M2. And what we have here excuse me, is the x coordinate of the point. We shall come back to this. So similarly we can consider again back to our equation here. Let us call this equation star. So if we go back to star and pick another relationship or another relation, we have M1 M2. We want to pick with Q1P and Q2P2. So similarly we have M1 over M2 equal to the last one, Q1P over Q2P2. We want to work with this, okay? And this is equal to what? So what is Q1P from here? Q1P is y minus y1 is y minus y1 over Q2P2 is y2 minus y. Q2P2 is y2 minus y. So once again, we still bring it as so what we have here is M1 over M2 equal to y minus y1 over y2 minus y rather. So just like we had done before, we're going to cross and then make y the subject of the formula here. So if we cross this, we're going to have M1 into y2 minus y equal to m2 into y minus y1 into y minus y1. So if we multiply, if we expand, we're going to have m1 y2 minus m1 y equal to m2 y minus m2 y1, of course. Now if we factorize y from the right hand side and carefully do it, we're going to arrive at y equal to m1 y2 plus m2 y2 all over m1 plus m2. So if we call this value here equation, say 5, and call this one, say equation 6, then the coordinates pxy, the coordinate xy of the point P that divides the line segment P1, P2 internally is what? Pxy equal to P into, what was our x coordinate? Go back to equation 5. Okay, this means this should have been x1, x1, and x1. That is, we have m1 x2 plus m2 x1 over m1 plus m2. And the y coordinate is what we just obtained in equation 6, which is m1 y2 plus m2 y1 over m1 plus m2. So with this, we can get the coordinates of the points P, x, y that divides the line segment internally. Now the question is, what happens if the point P, x, y divides the line segment externally? Then we'll have that P, x, y is P into m x2 minus, instead of plus, now you have minus m2 x1 over m1 minus m2 for the x coordinate. And for the y coordinate, we have m1 y2 minus m2 y1 over m1 minus m2. We must now make an important remark. Now if we have here, this is our points P1 and point P2, and the lines and the point P, x, y that divides internally is this. Question is, what if this point PXY is actually the midpoint of the line segment? Okay, yes, this point PXY is an internal point, we know. But what if in addition to being an internal point, the point PXY is the midpoint, the middle of the line between P1 and P2? Well, in that case, the ratio of division will have to be the same, right? That means M1 will be the same as M2. So M1 and M2 will just be the same. Are we there? Okay. So what will now be the coordinate of X and Y in this case? It will now be, so you know the X coordinate from here is this. So it will now be, the X coordinate will be M1 X2 plus M2 is also M1 because they're the same. M1 X1 over M1 plus M1. Okay, so this gives us, we can factorize M1. Now we have X2 plus X1 over 2M1. So M1 and M1 will knock off, and we have X equal to X1 plus X2 over 2. So if the point PXY that divides this line segment is at the midpoint, then the X coordinate becomes X1 plus X2 over 2. But if the point PXY is just an interior point or internal point, which is not a midpoint, then the X coordinate is nothing but this. So similarly, the Y coordinate will be Y1 plus Y2 over 2. So in our next class, we shall put this formula we've just gotten today into use by solving one or two examples. So if you've liked this video, you click on the like button, share this video, and also please do not forget to subscribe to this channel. Thank you.